In this video, I'll show you how I wire headlights and brake light on multiple vehicles, including, but not limited to, go-kart, dirt bikes, UTVs, ATVs, mini bike, and other off-road machine. Every vehicle is different, so what worked for me may not be suitable for your setup. Please take a moment to read the caution and disclaimer shown on the screen and included in the video description. Thanks for watching. For the purpose of my video, I'll use those clips here that you can just pull up. And the only thing it does, it connects any wire that I put in those holes right here together. So just to make it easier for me for the video, I'll get the positive here. Whatever I put here will be bridged back to the battery. So that's the only purpose for that specific. So in my case, for the ignition switch that I already checked, I'm at the off position. The red wire will connect to the battery. When I turn the key to accessories, the white wire have power, and that's what I use to trigger the relay. And in my case, the green wire goes to the starter relay. But I'm not using it, so right now I just cover it just to protect it, to make sure that I don't do a short with this wire. And that would be the ignition switch I'm using. So in my case, ignition switch are not made to use or draw high current. So that's why I bypass the switch with the relay. So the switch should be rated for 10. The problem is if you keep drawing a lot of power through your switch, what will happen? The switch will actually eventually fail. So in my case, I use one of those relay. So what happened is those two wires here, the yellow and white, as per the top of my switch here, 85 and 86, when I'll put power on, what will happen? It will trigger that little switch here, and it will trigger the relay. So at this point, this one goes to ground, the yellow one goes to ground, the white one is the trigger from the switch that we just checked a few seconds ago. Red one will be the power coming from the battery, and at this point, it will go through the relay and give me power on the black wire. So now, depending on which one you buy, you will get different color. So don't use the color itself, but use the top of the relay here to actually tell you where they go. So 85 and 86, as you can see, is the coil. The 30 is the power coming on, and 87 is the power going out. So in this case, they come in different color, but if you notice, and you'll see it when you purchase one, those are smaller. And where the power goes, because it's rated for 40 amp, the power is bigger. The battery I'm using for this wiring harness is a YTX12BS. If you read on this battery, it's 12 volts, 12 amp hour. But in reality, I check online to get the accurate information, and it's actually 10 amp. So it's a mislabel or something. But in my case, I'll calculate that the battery is 10 amp. All the wire I'm using in this video are 16 gauge. 16 gauge is good to 10 to 13 amp. So now with the battery being 10, so this for me is 16 gauge wire is a safe wire to use. So the first thing I want to do is actually get the positive from the battery. So I'll connect it here. So after that, I've got my ignition switch wire here. So now I know the power going in the switch will be this red one right here. And I'll just connect it here. The next step, I'll need a fuse for my relay that I will put right here. So at this point, I've got the power that I will use here with this red wire that I will connect right here. So now at this point, I've got power coming here, going down, going to my ignition switch, and I also bypass the power to come through this fuse right here, connect here with the relay. So my next step will be my yellow wire, who's actually ground in my case, on that specific one. So now I'll just plug it right here. And the next one, this relay will be triggered by the white wire from the switch to this one right here. So what is happening right now is I've got power coming. The power, when I turn the switch on, will come here, trigger the relay here, who will be grounded there. And after that, the red one will bring the power in, and that will become, the black one will become my new power source for everything else I will plug after. So in this case, I use this fuse just to protect the entire circuit right after. So if I take this wire here and I short it or anything, it will blow up the fuse. So at this point, I should be able to plug my ground here. I'm gonna need my ignition key. Plug it here. And if I listen carefully, when I turn the switch, the relay will clip. So at this point, that will be my new power, secure with a fuse, using a relay so I don't use the ignition switch to draw all that power through. And at this point, if I forget all those wires, this one here is my new power, and the green one here will be all the grounds that I will put there to close the circuit. So at this point, the only thing I create is just a bypass for my switch with a relay. So now my power, everything I need for my light will come from that black wire, and I'll use here the green wire that I will connect here for my ground. So now I'll use this piece right here. So now that will be my low beam, off, on. I've got a little gauge here that tells me the power that it will be required to keep an eye on the power use for my lights, and also the health of the battery that I'll explain later. And this one here will be my bypass switch that I will explain also later in this video. So now if I want to connect this here, I already pre-wire some. So now imagine that all those wires are touching. So now I need my power here. So now I'm bringing all the power to those 3 wires. In the back here, I'll get the positive from the voltmeter right here. And I also know that the middle of that switch here will require power to turn on my light. So the next step will be to put the green wire here, ground it with my junction here, and now what will happen when I turn the switch on, I'll be able to read the power from my battery. So here's how it works. I've got my volt gauge here, and on the back here, it might be hard, but this one is positive, this one is negative. So as soon as I connect those two to a power source, it will tell me the voltage of the battery. The next one will be my switch here, low, off, high. The way it works, this is actually two switch. From the left and the right, they're not connected together. So now if I bring the power in those two here in the middle, when I'll put the switch to low, it will actually connect this one and this one independently from this one and this one. When I put it to high beam, like so, because it's a rocker inside, it just moves and it connects those two pins together and those two pins here also. The same principle for this switch here, but this one it's only on off. And if you notice, when I put it on, the two wires are at the bottom. So now power coming in, going down on this one, and the same happen here. But again, this is split, so it's like two switch. So the next step will be to get my connection done for the lights. So in my case, I use a 3-prong, 3 terminals. So the green wire, if we just move those one, the green wire will be ground, the white wire will be high beam, and the blue wire will be low beam. And you'll see it with the light later. So now in this case, I disconnect my battery for the time being. I'll put my green wire here to the ground. My blue wire will come here on the top, because when I push that switch, as I showed earlier, when I push it down, it actually put the voltage through my black wire here and the blue wire. And the white one, actually, I'll put it right here at the bottom on a different side. So now this side will control my low, and this one will control my high beam. Actually, you could also just use this one here, if I just put it there. The problem with that, when I'll use this switch later, it won't work. So now in my case, I'm putting the high beam here. So the high beam goes right there at the bottom. Power coming with the black, and the black here will bring the power to the low beam. So now my next step will get to get those two connector plugged. So in my case, this one is the high beam, and this one is the low beam that I'm using. But now, because we have 3 wire, low and high on both, it doesn't matter where I plug it. As long as I put those 2 wire right here at the right place. So now see, I have my green going to the ground on that side, and the blue one is going to the red. Now on the one that I call my high beam, you'll notice when I plug it here, I've got the green going to the black wire, and the white wire, like I said earlier, it's high beam, and I plug it there. So if I put those 2 lights here, put my ground back, so now my key is on. If I put low, the bottom light will turn on. Turn it off, and if I put the high beam will light up. So now in my case, I have an issue. I have 2 lights that are single beam, but I'm using this one for the low beam and this one for the high beam. But now when I turn it on high beam, I want all the lights to work. So I'll show you a bypass on how to do that in a second. So now that I want my light to all work at the same time when I'm on high beam, I'll actually use the switch right here. So let me just zoom in just a little bit right here. So now in this case, I'll remove this wire, and I've got one right here that I've got kind of a Y. So now this one will go right here, and I'll bring it on this side here. The bottom one, I'll do the same principle. Put it here to the switch and put back my original wire here. So what happened? When I put it on low beam, it brings the power from here to here and will actually turn my lights on. But when I put it on high beam, on the other side, now the power is coming from here, going through here. If my switch is on, it will come back here and put the power back through that lead right here and give me power to my light. And I'll just show you the example right here. So now if I turn it low, let me just zoom out. So now my low beam is working, high beam working. I turn this switch on and it turns the low. So now it gives me more lights, but on the other side, when I'm on low beam, it will only turn the low one. So that's why at the beginning, when I was doing it, I used two-sided. So this way they don't interfere with each other. So now I have the high. I don't need the high that much. So at this point, that's why this gauge here is actually there, because you have a certain voltage that you need to respect. And I'll just show it to you in a second for the voltage. So now if I just put all the lights, see right now I'm at 13.8, who's actually a good place to be. So it charges the battery, so it doesn't suck too much power. But right now I'm only on the battery and a small charger. When you'll put it on your machine is actually different. So if you keep an eye on that and keep it at 13.8, you'll be good. But I'll just show you a schematic in a second and enumerate everything. So this is the plan for the power. So if you're lower than 12.5 volt, the battery is not charging and maybe actually discharging. If you're between 13.6 and 12.8, battery is fully charged but not charging. If you're between 13.2 and 13.6, charging at a low/maintenance level. Normal health charging range will be 13.8 to 14.5. That's why I just said a second ago, the 13.8 is really important. So you try to be as close as 13.8 without going lower than that. And if you're charging more than 14.8, you're actually overcharging and possible regulator failure. So that's something that you will be able to gauge with the gauge I showed you earlier. Here's another example. So on the left side, I've got a 3/4 inch garden hose, who's actually representing my stator. So now the power is coming through, charging. So my battery is actually the bucket right here. And on the other side, I have a 2-inch hose. It's the power demand. So now I'm asking more power than what the stator can push, and the bucket will actually get empty. And at a certain point, if the bucket, in this case the battery, get empty, the stator will blow up after. So that's why the voltage I just showed earlier is actually really important, because now if your demand is more than what you can actually produce, it will damage your battery, and eventually you won't be able to charge it anymore, and can also damage your stator and regulator on your machine. My next step will be the brake light here. So now if I follow my wires here that I already did, so if I split those wires, the green one is the ground again. The yellow one that I'm using is actually when I push the brake pedal, and the brown one is actually the daylight. So the light will turn on when the machine is on. So the first thing, again, I'll need power. So now I'll use my block that I used earlier, who's got the plus 12 volt. Put that wire in. And at this point, I've got this connection right here. Like so. So now I have plus 12 volt coming here. So in my case, I've got the brown coming here and turning the lights on. So right now, if I test it, actually it won't work because I also need my ground, who's right here, and I'll put it right there. So now at this point, if I turn, my light will turn on. But now there's one more step. So I have plus 12 coming from this yellow wire, and this one is the side of the light. So to turn on my brake light, if I touch those two, I'll pretend to be the switch. And you can see the light just turns on. So now those two wires, soon I touch them, turn the lights on. Usually on one of those machines or anything, you'll have the two prong here, and this one is a pressure switch. So when you push the brake, the fluid goes in, push the diaphragm in, and connect those two right here. So in my case, just to make it simpler here, I just touch a wire. Same principle, same way of working. If you do it for a motorcycle or anything, it will be on your lever. You'll get a wire coming out. And what happens is when you push the brake, it pretend, and it just touched the two wire. So at this point, I could change any of my lights. So now my switch is off. I could remove those two lights here, put them aside, bring back my original light from my machine because I follow the same pattern. I could just plug those lights in like so, turn my key on, my brake light will turn on. Now I have my low beam, high beam, and in this case, even if I turn this switch on, it makes no difference because those lights are LED, and the way they work is only the bottom will turn on at the low beam, but when I switch to high beam, the bottom and the top turn on. So it rendered that switch. Makes no difference. And I'm still at 13.7, and that's on a charger. So keep an eye on those, but you would be able just to disconnect, get your two connector, and plug any lights you want. As long as you respect that 13.7, 13.8, and you don't go lower, the battery and the charging system should survive. So in conclusion, right now I've got all those short wire, but for your machine, your motorcycle, any machine that you have, you can just extend your wire and it will work. So as I said earlier, I'm using those connection here, but in reality, you can get some of those copper shield right here. And what you would do is to actually put your wire in those sleeves that you can get in different size, and you would crimp them with this tool here. So now you'll put your sleeve, you crimp it, and after that you can put heat shrink on it or electrical tape, and it will work. So it's only a matter of the length of the wire when you'll do your own machine. And also in my case, if you notice, I've got like one of those bezel. It's actually a kit I built. So now all my switch goes here. I have my screw, /bolt, and in the back and front, I can remove them. There's some threaded insert. And this part here, that's where all my wires are coming through. And this part too is removable. So now I just slide it. I slide all my wire. Everything's coming in that enclosure. So now it's all safe for the weather. The relay's in it too. And my wire's coming out. So just make it nice and clean. So wish you luck. If you follow what I say in the video and you go slow and you calculate the size of your battery, the fuse and everything, you should be fine.